1. Server-side fundamentals. High priority. First, what happens when a user hits an API endpoint? When a client sends a request, it goes over the network using HTTP or HTTPS and reaches the server's web server or framework. For example, an Next.js API route or a Node server. The server parses the request, runs it through middleware like authentication or validation, then executes the handler logic. So before it executes the logic, just like with Flutter, it has security. So it has authentication before it passes through that. That logic usually talks to external systems, a database, cache, or third-party service. So that logic that is invoked after it is secured are usually talks to another backend, which could be a database, or it could be a cache from database, it could be a cache from that server or third-party service. And once that result is ready, the server builds a response and sends it back to the client. The important is that the server itself is stateless. All persistence lives in external systems like databases or caches. So that server is stateless, kind of like it's running the code that has memory, but it doesn't really persist it. If you kill that process or that server, it will not, if you didn't persist that data, it will not be saved to the database. It's like request to its middleware, which is the authentication, to logic, to data, and then response. What does stateless server actually mean? A stateless server means that no user-specific data is stored in the server's memory between requests. Each request must contain all the information needed to process it, because it didn't cache it. Therefore, in each request, you need to include all the information rather than preferring the default or having all this necessary information. You would need to go all this process, which is, by the way, bad design, because it has a lot of cognitive load. So the ideal way really is to select or to choose a stateful server. So each request must contain all the information needed to process it, usually via headers, tokens, or cookies. So that's usually the cookies or the tokens in case of the JWT token, and the headers from HTTP. So those are the usual additional information you would have included. If the server do not do a persistent session, which is like a persistent session handling, this makes scaling easier because any server instance can handle any requests, and we can add or remove servers without breaking user sessions. So in a stateless server, there's an advantage is that when you have an instance or a code process running on the server's memory, you can just delete it because it didn't really save any important information regarding the session of that user, because the user will have to add all the necessary information anyway, including body, header, tokens, or cookies. So stateless equal horizontally scalable. That's where the horizontal and vertical scaling came. How does authentication usually work in modern web apps? Typically, authentication is handled using tokens, most commonly JWTs. After login, the server issues a token that represents the user's identity and permissions. On every request, The client sends that token usually in the authorization header. So that token are actually being sent in each request, not just after the server sent it back or responded back to the client. So that token represents the user's identity and permissions. So on every request, the client sends a token usually in the authorization header. So just like the authorization header that must be included in each session or in each request of the user, that's also where the JW token responded from the server are included. The server verifies the token, extracts the user identity, and uses that information to authorize the request. So after it verifies the token using that middleware, it then now extracts the user identity and uses that information to authorize the request and then get into the business logic without needing to store session state in memory. Token is equal portable identity. So what makes also that horizontal scaling possible is the use of this token. Because if you use the token that is included in each header, it makes it portable to other server instance in other data center and other server. What's the difference between a database and a cache? A database is the source of truth. It's optimized for durability and correctness. A cache is a performance optimization. It stores derived or frequently accessed data in memory, so we don't recompute or refetch it every time. The key challenge with caches is invalidation, deciding when cache data is no longer correct. So DB is equal to truth, cache equals to speed. So we kind of know what cache is, but the key word here is the optimization. When we do cache, we're really trying to optimize performance. And those data that is derived frequently are accessed in memory. So we don't have to recompute it in CPU. Basically following the basic principle of CPU memory disk. So the key challenge with that is invalidating when to stop putting that in memory to avoid overloading or to avoid getting or carving out some resources that is not needed. How would you think about cache invalidation? Cache invalidation is about defining clear ownership of data changes. Whenever the source of truth changes, we either invalidate the cache immediately, set a TTL, or version the data so stale values are ignored. So again, cache invalidation is about defining clear ownership of data changes. So you would need to have like a clear permission settings to be able to execute cache invalidation. Whenever the source of truth changes, we either invalidate the cache immediately, set a time to leave, or a time for that cache to expire, because some like use cases actually are able to use the same data even though the source of truth changes for their particular purpose. So the data's so still values are ignored. The simplest strategy that works is usually best. Overcomplicated caching tends to introduce subtle bugs. So these simple strategies such as versioning like we did in Redux and expiration uh, seem simple but very effective in cache invalidation. So the simple strategy that works is usually best over complicated. So invalidate when truth changes. Node.js and server execution model. How does Node.js handle concurrency? Node.js uses a single-threaded event loop model. It handles many concurrent requests by performing non-blocking I/O when it waits on network or disk operations. It doesn't block the main thread. So, CPU heavy work should be avoided or moved to worker threads because it blocks the event loop and affects all requests. So what this single-threaded event loop really means is that the worker, or you can say the operation or the non-blocking operation, are executed so basically it handles many concurrent requests that is not a blocking I/O. So what that means is that for network or disk operation that requires outsiders, such as like other thing in or other server in the network, or um, a disk operation which takes more time to complete, it actually separate those to a non-blocking I/O, which is operations that or request that is not blocking or does not need those dependencies. So it execute those concurrently. So CPU heavy work should be avoided or moved to worker threads because it blocks the event loop and affects all requests. Additionally, aside from having a single-threaded event loop, which has a single thread on that event loop model, is that it also organizes it in a way that all the operation that requires heavy work, CPU heavy work, should be moved to worker threads. So that's another threads because it blocks the event loop and affects all requests. So event loop, not threads.